This is a short demonstration of how to measure current with our multimeters. Now, to measure current with our meter, we have to modify the circuit to put our meter in series with the resistor. This differs from measuring voltage. If we look at the circuit diagram that we have for this circuit again, if you haven't watched the video on measuring voltage yet, you should do so. We have a resistor connected to a battery. To measure current through the resistor, we have to connect our meter in series with the resistor. The circuit diagram should look like this. Now, if I follow the path that current can take through this circuit, we see that any current that runs through the resistor will have to run through our meter as well. And this is what we want. For this simple circuit, it is not too difficult to really understand what we need to do, but for more complicated circuits that we'll build in next week's labs, the same thing is true. We have to connect our meter such that the current we want to measure must go through our meter. Now, I've already mentioned the danger of breaking our ammeter in the voltage measurement video. In that case, we needed to be sure to switch the multimeter to DCV before connecting it, because we were going to connect it in parallel with the resistor. In this case, we need to be careful not to connect the meter in parallel with the resistor while it is set to DCA. So we set our meter to DCA, and we connect it in series with the resistor. The circuit diagram looks like this. But here's a picture of what the physical circuit looks like. If I trace the wires starting from the positive terminal of my battery, I see that the current will come out of the battery, go through my meter, then go through the resistor, and finally back to the battery. So my meter is in series with the resistor. Now let's measure the current as accurately as we can. We start with the dial on the highest current setting. Note that the highest current setting is at the far clockwise position for DCA, which is the opposite of DCV. Also note that the current in my case is being reported as negative, but this would be positive if I just swapped the meter probes. My measurement here is 1.5 milliamps because we see that the max current is listed as 200 M and M stands for milli. Going to the next lowest range gives 1.58 milliamps. The next range gives 1411 microamps because the max range is listed as 2000 micro. And the smallest range displays a 1, so the current exceeds this range. We would then switch back to the 2000 micro setting, and our measurement is 1411 plus or minus 1 microamp. Or we could say 1.411 plus or minus 0.001 milliamp. Or we could even write this as 1.411 times 10 to the negative 3 plus or minus 0.001 times 10 to the negative 3 amps.